Hey everybody, hi Celeste, hi Baz, hi Bill, hi Daniel. What we have here is Earth may have been a water world 3 billion years ago. You don't say. This paper right here says limited Archean continental emergence reflected in the early Archean oxygen-18 enriched ocean. So just kind of taking that and translating it into meaningful words. They took samples of rocks, and those samples matched samples that what they could expect for those samples having been formed in a deep ocean. That's all there really is to it. And that deep ocean existed on the Earth about 3 billion years ago. So the Earth is 4.5 billion years old. 3 billion years ago means the Earth is about about 1.5 billion years ago. And I have Neptune and Uranus between 1.1 and 1.2 billion years old. So that means that's in line with Earth when it was ocean world. About 1.5 billion years old is when the Earth was an ocean world. And that sort of fits on the graph right here. You have Earth right here, and then you have ocean worlds, and you have Neptunes. So what they're doing is they took the rock samples, and they discovered, wow, Earth was covered in a deep ocean. Of course, I've known this for a while. You guys have known this for a while. I don't know if they actually understand that the Earth is an evolutionary structure. From what I've seen in this article here, they don't quite get it yet. One of the researchers, what's his name? Benjamin W. Johnson. He says here, an early Earth without emergent continents may have resembled a water world, providing an important environmental constraint on the origin and evolution of life on Earth, as well as its possible existence elsewhere. Boswell Wig of the University of Colorado, that's the other guy that published this paper. I'll print out the abstract right here so you guys can see it. Boswell Wig of the University of Colorado Boulder, and his former postdoctoral student Benjamin Johnson, now at Iowa State University, launched a project to break fresh ground in a debate over what ancient Earth might have looked like. Their work centered on a geological site called the Panorama District in northwestern Australia's outback, where a 3.2 billion year old slab of ocean floor has been turned on its side. Locked inside the ancient crust are chemical clues about the seawater that covered Earth at the time. Yeah. The entire Earth was covered in a deep water ocean. Everywhere you stand was the sea floor. Hate to break it to you. Everywhere. Some parts are older than others, but they're all ancient seafloor materials. That being said, I don't know if they fully get it. I don't know if they fully understand what's going on here. This discovery that was made in 2011, from my perspective, some others have made earlier realizations of it. Alexander Oparin discovered the Earth as an ancient star back in 1924. So almost 100 years ago he discovered it, but of course he got trapped with the Soviet mentality, and they sort of put, the Iron Curtain down, and a lot of information didn't come out from those periods on, Cold War era, but essentially, one day, this debate on what early Earth looked like that Boswell A. Wing and Benjamin W. Johnson are having is going to be fully recognized as what it truly is. and that we have the observations of very young Earths inside of our solar system even. Jupiter is around 700 million years old. Neptune, Uranus, 1.1 to 1.2 billion years old. The sun, I have the sun as extremely young. I have the sun, gosh, hate to say it, but it's about 10 million years old. I know people are going to be very upset with that, but 10 to 14 million years old, probably. It's a very young Earth. Very, very, very young Earth. And to look at these people, I mean, they're not stupid. They can do these measurements, and they can do all these jumping through the academic hoop type things. But really, I think they fail in understanding that it takes time. It takes time for something like the Earth to form the way it is. They're sort of looking at the Earth, and they're assuming, oh, well, it had to have been mostly the way it is today, for the most part. But they sort of ignore the fact that it's 4.5 billion years old. They don't comprehend the extreme time that is. They never ask the question, why should the Earth be 4.5 billion years old? Well, the reason why the Earth is 4.5 billion years old is because it took 4.5 billion years to form. Now, that being said, if Earth took 4.5 billion years to form, what would Earth look like when it was 1.5 billion years old? And I think that's what they stumbled upon. They were looking at rock samples that told them, hey, the Earth was covered in deep water oceans when it was 1.5 billion years old. And if you go a little bit further than that, you see that Earth resembled Neptune and Uranus at 1.1 to 1.2 billion years old. If you go further than that, you get Saturn and a Jupiter. Saturn is about 550 million years old. Jupiter is around 700 million years old. And if you go back, just like I said with the sun, all the way back, see, we don't have red dwarfs in our system. Red dwarf would be like the 200 million year old range. And the brown dwarfs are about 300 million years old. We don't have those in our solar system. We just sort of skip over them like a fruit salad. There's no continuum in our solar system, but we do have a few objects that show us what Earth looked like in its past, and we have some objects that are going to show us what Earth will look like in its future, its far, far future. But it's sort of still lost upon geologists and astronomers that Earth is a highly evolved structure, and that we have the observations now with exoplanets of objects that were much less evolved. And a good general rule of thumb for those who are new to this theory is that the larger the object you have, the more massive, the more energetic, the younger it probably is. It's going to be very unusual to find a Jupiter-sized object that's going to be older than the Earth. It would be very unusual. It would also be very unusual to find an Earth that's 10 million years old. There's no way they're going to find an Earth that's 10 million years old. It takes nature, it takes a process of stellar evolution, billions of years to form something as massive and as evolved and as differentiated as the Earth, as complex as the Earth. It just doesn't form overnight. And it doesn't form in 10 million years. It takes billions of years for this bad boy to have formed. And I had the distinct privilege of going on a trip to Tennessee, hanging out with my family, and we got to see some of the old Smoky Mountains. It was a lot of fun driving through those things and seeing the rocks that were originally flat get pushed upwards like this, and that's what made the mountains. And to see these large land masses just going complete diagonally, like, imagine all the force it took to crush those things together as the crust is collapsing on itself. The crust basically collapses on itself, and when it does this, it goes like this with the mountain range. and then there's weathering, and then the weathering happens, and then you can rock up to some of these rocks and just pop a little bit of the outcrop off with your hand, and you have these sharp stones, which is really cool. But yeah. Okay, guys, I think that's it for this talk. I wanted to share that new discovery with you and show you that, well, I've kind of sort of known about this for some time, and I'm not even really frustrated anymore with it. I'm just sort of, let these let these people do what they want to do. Let them, you know, pretend that it hasn't been figured out already. Let them argue and play their little academic games or whatnot. All right, guys, today is March 4th, 2020. Take it easy.